I want you to please go into this QR and start scanning this QR code. If it doesn't work for any reason, please let me know. Okay, I just pasted the link in the chat. Please click that link and it would probably prompt you a message that says allow access to your camera. In that case, say yes for this exercise, and then we'll start working on that. Perfect. All right, so as you know, the topic for today is about computer vision. This is just a platform for you to kind of play and explore the different models and the different parameters that there might be available when you're building a computer vision model. In this case, we are practicing with object detection. So we'll talk more about what it means, but just to give you an overview, this is what the model has been trained for, to detect the different objects in an image. You can play with the parameters here in your free time, but for the sake of this exercise, I'm just gonna go very quickly over here. So you can see that this model is detecting a person, a couch, or chair, and it says air. I wonder how it detects air. The next model that I want you to try, it was the gesture recognition. So if you are in the link, go on the left side and click here on this side where it says gesture recognition. Here, what this model does is to recognize hand gestures. However, it only recognizes, as you can see here, 7 classes. So here, as you can see here, it's detecting thumb up with a 64% of accuracy. Now, if I try thumbs down, it's a little bit more accurate. I can try this sign, which is victory sign, with an 85%. Let me turn it around. It starts kind of going up and down. What other? This one, closed fist, 50, 63%. Let's see what it does if I move it. Also open palm. And then what is this? Doesn't show anything. That's weird because it shows none, but it says that it was trained here. But this is based again on the training data that you've been using for that. So Matsume, if you're looking here at my screen, you will see here this 82%. This is the certainty that the model has that the sign that I'm doing is a sign of victory. So it is confident. It has a confidence of 83, 84% that that's the victory sign. You're welcome. And the last one that I wanted to share with you today, let me go back here to my notes, is face detection. This is a simpler model, and this is only going to detect faces. So it's been trained only in faces. So it's going to tell you what is the probability that this is a face. So there is a 96, 95% certainty that this is a face. So yes, this was the different 3 exercises that we were going to practice today. Feel free to practice with your family members to spark their interest and imagination, or if you have kids, practice with them, because this is a great way to get them on board on the fascinating world of AI. For those of you who I haven't had the pleasure to meet, my name is Maria Becerra. I'm a Colombian engineer and business analyst. I'll be today your facilitator for this AI Expedition series. For those of you who are not aware of what is AI Expedition is a community where we look to educate people with non-technical background in the world of AI. And the idea is to democratize knowledge, because nowadays there's so much information on the internet that it's so hard to get it started. So we try to make this a little bit fun, community driven, so that we can all learn together without the technicality of going into the coding piece. If you're interested into that, we can provide more resources, but for the sake of this community, we plan to do it more from a critical perspective. Like what questions I should ask, or what it entails, and so on. Just a couple of housekeeping items while we continue. This is supposed to be a community, right? So feel free to add your comments and questions into the chat at any point. I'll try to monitor. And if I miss something, I will ask my friends, Anjusha, Maria Paula, Masume, Leti, or Zoheb to let me know if I'm missing a question. Use the reaction feature to share feedback. So I just asked you a few seconds ago if you were, if your link was working. It seemed that everyone knows where is the feature, so that's great. If you have a pressing question and I don't see it, raise your hand or actually unmute yourself. Again, this is a safe environment and the idea is for all of us to participate. And lastly, from my personal experience, I recommend taking notes because when you're taking notes, it's easier to pay more attention and be more engaged in the presentation. And then it's up to you if you want to share them with your friends, colleagues, etc. So as I told you, the topic for today is computer vision. Our speaker is or was Raquel. She's from Bolivia, but unfortunately, she had a medical situation and couldn't join us today. So I'll be taking her spot. So if any of the questions that you ask, if I don't have the answer, I'll check with her, we'll research together, and we'll find the answer. Okay, I'm using here another website. Please give me again thumbs up if you can see the slides. It should say the power of computer vision. Okay, perfect. Thank you so much for the thumbs up. And thank you, Nancy. All right, so let's get it started. This is the content that we are gonna cover today. So first, brief overview of concepts. Then we're gonna check how computer vision works. We're gonna check some applications. Of course, the real world examples, which is what I think would help us more in our job. And then finally, we are going to look at some quick videos of implementation. As I said, Raquel might have another session in the future for those interested in something more hands-on, like building their own computer vision model, etc. But this session webinar is going to be focused more on the concept and application side. All right, but what is computer vision? So if you recall from our very first session back in January, we learned that artificial intelligence is a broad field. So think about AI as this big umbrella. And within this big umbrella, there are different subfields. So computer vision is one of those subfields. It's a subfield that enables computers to interpret and make decisions based on visual data from the world. So one of the most common examples is autonomous vehicles. You have an autonomous vehicle that then detect a stoplight. If it's red, stop. If it's green, continue. That's the easiest way to imagine what is computer vision. And this involves, again, processing and analyzing all the images and videos around these systems to extract meaningful information and then take some action. I just gave you this example of the autonomous vehicle, but then we are going to check other examples that might be more related to your job. There is a little bit of history, but we are not going to get into the details of this history. This is just to let you know that computer vision is not something new. Computer vision, as you can see here, comes all the way from the 60s when Larry Rover presented a thesis on 3D object recognition. Then there were some development on more algorithms and feature-based methods. This is just to extract meaningful information from this picture that was in the 80s. Then in the 90s, we got some more machine learning models that had better performance on the different activities that it was doing. Then in 2012, we have AlexNet's success in the ImageNet competition. AlexNet is the name of a model that was able to really understand the images better and predict outcome with a better performance. And then in the 2020s, we got the introduction of vision transformers, which was a better way to, again, predict images with a higher performance. So again, the takeaway from this slide is that computer vision is not something that is new. It's been around for a lot of years, and it means that it has just got better and better along the time. Some of the key components of computer vision, as you can see here, include 4 main topics. The first one is all the image processing. So these are all the techniques for enhancing and transforming images. Say, for example, you have, let me think, this pen, right? So you have an image of this pen. If you have only images of this pen with this position, like facing this little thing facing down, and you train your model on this data, if then you give it a picture of a pen facing the other way, it's not going to predict it, or it's going to predict it, but with a lower performance. So these image processing are techniques that help you get these pictures, but then it starts turning it around and gives you many more images so that your model is trained with more data, with more variety, so that when you give it maybe a picture of a pen looking down, facing down, or with other colors, it can predict it with a good accuracy. Then we have the feature extraction. This is another concept where we identify important features or patterns within images. If you have looked at your Google Drive image section, you will see that it starts classifying all your pictures with different faces, and it even tells you, oh, the name, all these pictures belong to this person. I don't know if you have seen that feature. I have it on my Google account. It starts classifying all my pictures. And even if you write in your Google photo database something like documents, it's going to give you all the pictures that have documents. If you haven't done it, I highly recommend it to go and try it, because it is a very cool feature. Then we have object detection, and that was the exercise we were doing at the beginning. With this component, it helps you locate and identify the objects in an image. The model that we saw was only identifying about three classes, 3 objects, but there are models that are even more advanced, and it identifies all the little things that you see around, like dust, or if you look at a big image, it will start identifying screen, laptop, phone, pen, etc. So give it a try again with the model that we checked at the beginning, and move the parameters around to see if it can detect more things in your house or in your environment. And then we have image classification, where we categorize the images that we provide to the model into predefined classes, like the gesture recognition that we saw at the beginning. So again, it depends on the data that you train your model to predict certain classes. If you have any question, again, please write it in the chat or raise your hand or unmute yourself. Now, let's move into understand a little bit of how computer vision works, because we have seen now some key concepts, but we haven't seen like the full picture. So to do an analogy, we as humans recognize objects or images when we have first, let's say, a tomato, an image, right? Then we have a sensor. In this case, it's our eyes. And then the images that we capture through our eyes go into our brain. And then because we have seen tomatoes in the past, because we've been trained to know that this image looks like a tomato, we can predict that this is a tomato. But if you see something that, like, I don't know, maybe a fruit or an animal that you've never seen before, even though you can see it and your brain can process it, it may not identify what it is, but maybe it can say, oh, it looks like an animal, or there is a percentage that this is certain fruit, etc. Machine learning models, or computer vision models in this case, works in a similar way. We have an image, and then we have a sensing device. Sensing device can be a camera. That's the most common sensor. And that information, after capturing that data, goes into the computer. In the computer, we've built a machine learning model to understand what is that we are looking at, and then have a result or a prediction, or what is the probability that certain image that we look at is a tomato or an apple or a peach, etc. Right? So this is a high-level overview on how it works. So now to break it into steps, first we need all the data acquisition, so capturing the images or the video, because at the end of the day, the video is just a sequence of a lot of images through the different cameras or sensors. After we acquire the data, as I mentioned, it goes through a pre-processing model. The pre-processing model was the one I explained, where we maybe move the object around, or where we change the colors just to give it a different tone. Then we have the feature extraction, where we identify key concepts or objects of our images. And then we pass it through our machine learning algorithms to then extract the information and make a decision based on what we are predicting. Any questions so far? Okay, good. And let's move on. Within computer vision, we have different tasks. So one of the tasks is classification. We saw it in the example. It was saying, yes, this is a face, right? We have a 96% of probability that this is a face. That's classification. Now, detection helps you identify what are the different classes that we have in the images that we are providing. So if you remember, there was an example where it was identifying, this is a person, this is a coach, this is air, this was a plant. That's object detection. Now we have semantic segmentation, which focuses on classifying each pixel by class. So as you can see in this image, it's detecting that all these over here, all these pixels are animals. And then the pink part, it's maybe background or noise of the image. Now we have another concept here, which is instance segmentation. This goes a little bit deeper to distinguish between the different instances of the same class. So here we were just saying, this is a big class that it's all animals. Instance segmentation goes level down to say, okay, within this class, we have two instances or two subclasses, which in this case is dog and cat. I'm going to pause here for a second, and I'm going to ask you where you would see this applied in real life. For what we have seen so far, what is like a real use case where you think we could use computer vision? I want you to see the comments on the chat, or if you want to talk, unmute yourself and let us know where you think we could apply this in real life. And you can say autonomous vehicle, because I already said that at the beginning. Yes, facial recognition for fun and love. Spot parking detection, that's another good one. Airport identify person, good. Access to security facilities. Those are great examples where we could use for sure computer vision. Thank you so much for sharing the insights. Core recognition on TD Bank. Yes, that too. Self-driving cars, our phones, yes, self-checkout systems, yes, like the Amazon ones. Great. Okay, thank you so much for participating. Now, this is how, okay, here on the left, this is how we see an image, right? Of course, a little bit more clear, but say, for example, this is the image we have. Here on the right, it's how a computer will see an image. A computer doesn't understand faces or doesn't understand fruits, it understands numbers. So you might have heard the term pixel. That's what a computer sees, but in a scale of numbers. So in this case, this is a grayscale, an image in a grayscale. And each pixel has a value that represents the brightness of the picture. These range from 0, which is black, so meaning the absence of color, to white, which is the number 255. So if you see here on the right, you will see that there is a 0, 0, 12, 0. So this part over here, it's this over here, so the black part. Now, that's why you see like a low number. But if you look at, say, this side, white, it's 255, 249, because that's the brightest part. So this is how a computer really see images. This kind of image is fundamental building blocks for computer vision. And it represents, again, the type of data that on how algorithm process the work. Where does the number come from, as you may ask? It's just a number that has been established. I really don't have the answer, Masume, but I can check and let you know in our next newsletter when we send the summary of this webinar. I just know that it goes from 0 to 255, where 0 is black and 255 is white. Yes, these are the pixels, but I don't know like why it goes to 255 exactly, like why not 300? I don't know why it's specifically from 0 to 255. We'll check that and I'll get back to all of you. Okay, now let's move to my favorite part, which are the actual applications of computer vision. And you've already gone through some of them, but let's look at some other. So one of the good use cases of computer vision is in healthcare. And this is something that excites me a lot because healthcare is an area that needs a lot of help. We know here, for example, in Canada that we have shortage of doctors, and with AI, I think we can help with that problem. So in the past, we would have doctors looking at our X-ray, our scans, and so on, and then interpreting the image and giving a result. Now, imagine if a doctor can have an AI assistant that gives like a preliminary result or analysis of this image, and then provide some explanation on what it means or some diagnostics that then the doctor can confirm and then provide more explanation to the patient. From our end as users, if you're curious to understand your results, you can now take an image, pass it through tools like ChatGPT or Gemini to understand what it means. Just be mindful that probably this information can be shared with the rest of the world, so be careful with what you input there. I recently had some exams and I didn't understand anything. It was an electrocardiogram. So I passed it through ChatGPT and it explained what it means. It gave me some insights on what the different numbers are. So it's very cool that now information is being democratized and that everyone can have access to this type of information. Another use case, oh, and sorry, one more thing. There is a company, and actually it's a Colombian company called, each pixel is represented by a number from 0 to 255. Thank you, Elian, but we don't know why 255. Is there a reason for that? Let us know if you find something. But yes, going back to healthcare, there is a company called Archangel AI. It's a Colombian company, or well, at least the founder is Colombian, and they do something similar with the X-ray, Archangel AI. But what they do is to analyze all this X-ray and help doctors have a better understanding of the images to at least get started with the information. So that's very cool, and it's going to help a lot of doctors and a lot of people around the world. This is the use case we already saw, the automotive autonomous cars that have to recognize not only people, but all the different nuances around. Now, imagine if you have a car and then you have trained these models to recognize what is a person, right? But then it comes Halloween, and then everyone is using customs, like dinosaur customs. It's gonna get tricky for the model to understand that that is not, that is still a person. So we gotta be very careful, and those are the type of questions that we need to ask when we are working with machine learning engineers. Like, have you identified all the different nuances that an environment can have. Or if you go to a country like, well, I'm just gonna say other country where maybe there are a lot of what is the name, like holes on the roads, and where there's not a good structure, then we gotta be mindful again of that. Maybe what if we have trained all the trees with the information that a specific city has, but then we go to another city where there are new trees. What are you gonna do? Are you gonna detect it as a tree or not? So all those different things, all those different scenarios are things that we need to consider when building these models. And I'm going to show you here very quickly. Let me stop sharing and share with sound, because we have, well, not we, but there is an autonomous vehicle called Waymo. This is an autonomous vehicle, and of course, use computer vision. So let's see this video very quickly.
Welcome to the wonder of Waymo One, the world's first fully autonomous ride-hailing service. Now that you've got the app downloaded, you're ready to ride. To hail your Waymo car, just tell us where you want to go, and we'll automatically select the safest spot to pick you up and drop you off. Once you hail, you can follow along to see how far away your Waymo car is, and you can also check your estimated time of arrival to your destination. This may be updated along the way as we look out for things like traffic. You can edit your pickup and drop-off spots by adjusting the pin. The blue and green lines show you where the Waymo driver can safely pull over. You can add up to 4 stops along the way. If you need to run a few errands, grab takeout, or pick up a friend during your trip. Just be aware that the exact pullover spots may change due to current road conditions. Once it arrives, you can hop in and take off in a car that drives itself. It really is that easy.
Would you get the, like, if Waymo were available here or in your city, would you use it? Like, would you feel comfortable of it? Want to see your response on the chat. Let's see. Diana says yes, yes. Masume says not yet. Okay. There are so many feelings about this technology, and of course, it is normal that not everyone feels safe about it. So maybe we have to get a little bit more of time, but we'll see what happens in the next years. All right, let's move on with another application. The next one is retail. I think it was Maria Paula who mentioned that it can be used in the stores, for example. There is Amazon, I think it's called Amazon Go, where you can go and just grab your stuff, and then all the cameras around will identify which products you are getting. And then when you are exiting the place, it will give you a list with all the different items that you purchased and with the bill or receipt of your errand. But other than that, we can also use it. Sorry, here I'm gonna show you how Amazon is using it also in their warehouses. This is from a year ago, so this is not like recent, just to let you know. Okay, let's see how it will revolutionize our world. Let's continue here in the meantime. Another use case, I think it was Zoheb, I can't remember who mentioned it, but I think it was Zoheb who said also that we can use it for access to facilities or secure facilities. So This is a hard topic because we need to be very careful with the type of data that we are training this model. Imagine if in certain city, let's call it city A, in city A, most of the thieves are maybe Latinos. And then the data that you're using to train your model are Latinos, right? Because they are the ones stealing and robbing. And then when a person that maybe is from a Latino background goes and maybe it's in a dark zone and it's picking up something from the floor, then the camera recognizes it as a thief just because if it's from a Latino background, then you start getting all these biases into the system. So we gotta be very careful with the type of use cases that we are using AI for, because it may impact certain races, background, and some people that may not even be guilty of activities like this. So these are, again, consideration or aspects that you need to take into account when working with machine learning engineers or with the AI teams, or when thinking about potential use cases for your work. Another use case is agriculture. So with AI, you can recognize when a fruit or certain product is ready and available and is ready to be picked up. In that way, you can maximize efficiency, you can increase the revenue of your crop, because then you're going to know when is the right moment to pick up something. During my master's program, we built a machine learning model or a computer vision model to identify what was the disease of a tomato plant. And again, I'm saying tomato plant because that was the data we input, right? If we are going to work with tomato plants, we need to use tomato plants data. You cannot have like a general model and then go and use the same data for apple trees, for example. You got to be very mindful of the data that you're using to train these models. And with this model, in this project, we would look at the different leaves, and depending on the color, depending on the shape and size, we would identify what was the disease that this leaf had. And then we would recommend what was the right chemical that should be used to avoid that other plants got infected. So this is just a simple use case. There's a lot of also change management involved, because then you have to have your workers using their phone and taking pictures and identifying what is the right disease. And some people may not feel comfortable with that because they're going to think, oh, this phone is going to replace my job. So when working in an AI project, these are all the type of things that you need to think. We talk about the data, but it's also important to talk about the human aspect and how change management also plays an important role in these projects. Okay, agriculture. Here are some real-world examples that Raquel put here together. So we talk about the autonomous vehicles like Tesla, self-driving cars, facial recognition. I think Anjusha mentioned it, the Apple's Face ID. And this is very interesting. I don't know if any of you have like a twin brother or sister, but my cousins are twins, and each of them can unlock their Apple, which I find fascinating. So sometimes you have to give more data to your phone in order to ensure that there's more protection. But because these models have been training a lot of people, when it looks at your face and the face of your twin, it may find a lot of similarities. And because, again, this is prediction, it extracts the main features of each face and they find that they are similar, so it allows the access to the phone. We talk about medical imaging, like the MRI and the CT scans. The X-ray was another case. And we talk about applications in industrial automation, like the robots in manufacturing lines. So we cover a lot of things here, but one thing that we need to be mindful is that this is a very rapidly evolving field, and there are so many potential across various industries. We also know that continuous advancements in AI and computing power are driving the future of computer vision. And I want to show you, okay, let's look at this sentence. Computer vision is not only about enabling machines to see, it's about teaching them to understand and interpret the visual world around us. And before we ended up, I'm going to share Raquel's information. She was the person that prepared these slides and hopefully will join us in another session. But before we finish, I want to show another use case because we saw kind of very industrial examples or applications, but there's other examples that we can see more common, for example, in the financial industry or in your day-to-day role. So let me share here. Are you seeing the YouTube video, the one that says environmental ethics and weak anthropocentrism? Please give, okay, perfect. Thank you so much, Masume.
PDFs are images and don't contain any text. When you open a PDF like this, OrbitNote will notify you that it can't find any text. Just click Let's Scan. Select your document language and click Scan. OrbitNote uses a process called OCR, or optical character recognition, to make your document readable. When it's finished, your PDF will be ready to read, highlight, and annotate.
Before beginning these arguments, I need to clarify how I propose to test an adequate environmental ethic.
For more information about OrbitNote, visit texthelp.com.
Certain applications within which are closer to us, like OneNote. So this is a screenshot I took from the presentation. And as you can see here, this is an image. With OneNote, you can copy text from picture and then just paste it. This is using this platform, OneNote in this case, is using a subset of computer vision called OCR, object character recognition, which is helpful to extract data from images like license plates or text from images, or also if you think of signatures from a check. In the past, people would get a check, right? Like in the financial industry, you would get a check and you would have to validate if the signature of the person is first a signature, and second, whether that's a signature for the right person. Is this Maria's signature? So you would have to go back to other data and compare. That's what a human would do, and in many cases still do it nowadays. With computer vision, you can now have information of a signature and then the information of the previous signatures of the person, so training data. And then the computer compares these two images or signatures and say, yes, this is right, or no, this is not the same, and then it would send the information to a human for comparison. That's how the ballot system works in the US, where it is allowed to vote with signature or via mail. So these are other use cases that may feel a little bit more close to our day-to-day or our type of job or industries, because the other ones I feel are more industrial or more, in different industries or verticals. But this was a quick overview of what we wanted to share today about computer vision. I would like to know now if you have any other question for us or for me.
Maria, Zoeb, I have a quick question. Can you go to your last slide?
Which one?
Oh, yeah, I think it's the next one, because I think it was a conclusion slide. Is there a slide after this? I think there is a slide after this, right? Yeah. So we say that the computer vision is not about enabling machines to see, it's about understanding interpretation, right? Now, when I'm thinking of computer vision, right, I'm taking example of cameras, right? We have CCTV cameras installed at homes, or we have them at Dollarama, any stores. So do these cameras by technology have the ability to kind of capture images of or do facial recognition?
The cameras itself don't do it. Like the cameras are just the sensors. You would need to, some companies may have that incorporated, but the camera itself is just a sensor that captures that image or the video. If a company decides to add that feature of recognizing the face, that would be like an external chip or something that would go into the camera to identify that and maybe provide the information to your phone. So that would be something additional. But the camera itself is just a way to capture that information. So in order to recognize if that's a face, if that's a plant, you would need some extra hardware to connect that camera, and then you will need some model, some software, or the machine learning model to build the information or the formula, let's call it, to identify if that was a face or not. I don't know if that answers your question, Zoheb.
I think partially, yes. So it's almost like, how do I know whether my face or my image has been captured for some purposes through,
Okay, I see.
you know,
You would have,
yes,
yeah.
because like if we talk about the traffic camera, I know that if I were to get a speeding ticket, or let's say in some
Yes.
countries, they typically capture the image of the of the number plate. But
Yes.
then if it's like the enhanced one is probably, can they capture the image of the driver, whether they're wearing a seat belt or they're not wearing the seat belt,
Yeah.
right?
I get your point now. Yeah, it depends on the terms and conditions of the company of the product you are using. I heard some stories of companies that offer these baby monitors, and they were using that data of the babies for training purposes. So my friend was the one who told me, because she was going to buy one for her daughter, and she didn't buy it at the end because she thought that if you buy the product, your data or any recording will be used for training purposes. So, I mean, it's a lot of work, but we need to read the terms and conditions and check how our data is used. So good points, Zoheb, and it depends on the company.
No, thanks for that. Yeah, because I think these days all of us like to have, you know, it's easy, seamless access to everything. So whether it's
Yes.
facial recognition or whether it is fingerprinting, it's like, yeah, but how is it going to be used, and whether we even know?
Yes, and for example, I don't know if any of you have seen, but at the airports, there are now these quick check-ins where you just scan your face and then you can go faster. You are allowed to say that you don't want to, that you want to be opt out from that, and that you want to still present your passport, because you don't know how that data is used, and not many companies provide explanation on how that data is being used or stored. So to your point, yeah, we gotta be careful on that and ask as many questions as we can to these companies.
Yes, Maria, I have a question for you. Regarding emotions, is computer vision involved in this process? I mean, in the last release of ChatGPT, there's a video, a guy, well, it's a lady joking in the background, and the AI is saying that there's someone joking in the background. How it works? It's with the same type of computer vision that we saw today?
Yes, that's one way to do it, but you would need to have data for training purposes. So you would have data that says, this person looks happy, this person looks sad, this person looks like she's joking. And as you know, emotions are very hard to explain. You may be looking at that person with a serious face, and that person may be happy. But because we are used to know that happy people have a smile, then my computer or my model is going to look at the image of the serious face, and it's going to say, oh, this person is serious, this person is not happy. So we need good data. We need training data to identify what's that emotion. But that's one way to do it. The other way to do it is by training different things in the body, like the emotion, like not emotion rate, sorry, the heartbeat rate or the temperature of a person. Maybe your training data tells you when the heart is beating very fast, this person may be scared. Of if this person is feeling hot, maybe this person is angry. But again, we need training data, and it's hard to categorize all the data from all the world into certain classes. So we gotta be careful with that. And I think that's why there are not so many use cases around that. Also, the European Union AI Act prohibits or doesn't allow for AI systems to classify or to use data or systems to classify emotions. So that's another layer that we need to be careful of, where we are building our system, where we are building our product. Is it like it is compliant with all the different regulations around us, etc.? So different nuances, but I hope that it helps you also consider that it's not only about the data, but it's also about regulations. So many things to think about when building these projects. And I hope that answered your question.
Yes, thank you.
Sounds good. Right. Just have 3 more minutes, but if there's any other question, please let me know. Currently, Government of Canada implements computer vision at bus stop to reduce accidents faced by people while walking on the road. Do you think it also collects data? It may collect data, but we would have to go into the website of the Government of Canada and check how they are using that data. If they are using the cameras, the cameras, of course, is going to capture anything that is around that. The question is whether they store it or how they are using it. Are they using then that information for other things? Are they storing the data forever? What are they doing with that data, etc.? So we got to ask those questions. All right, the interest of time, I'm just going to keep moving here. I appreciate anyway, Raquel, thank you so much for providing all our slides that help us put together this presentation. I hope she feels better and gets well soon. And hopefully we'll have her in another session to walk us through an actual model build of computer vision. As for next steps, please mark your calendar for June 26th, 7 p.m. again, where we'll be discussing ethics in AI and all what we talk about today of the bias and all the different regulations and how we need to be very careful of all these topics when building AI products. Please follow us on LinkedIn if you haven't done so, join our community on Discord, and subscribe to our newsletter. And because you don't see the links here, I'm going to paste it on the chat. We've built one link with all these resources for you. So please go open it and bookmark it so you have ready. I want to say thank you to all our volunteers. There are so many to list here, but I'll make sure to write their names in our next slide for our next month. And also thank you to all of you for making time in your busy agenda to join us today and invest in yourself and learn more about AI. Thank you for joining us in this journey, and we'll see you again next month.